Hello everyone. This is challenging math problem number 8. We're going to be solving a system of equations in 3 variables, but the weird part of the system is that we only have 2 equations. And this is not a Diophantine equation by any means because we're not looking for integer solutions, but we're actually looking for the quantity x plus y plus z. So let's go ahead and get started. If you wanted to try this problem yourself first, go ahead and pause the video at this point and then check out the solution. Okay. So we are supposed to find x plus y plus z from the given equation. So let's go ahead and take a look at it here. We do have a system in two equations and 3 variables. So if this was a Diophantine equation, we were going to look for integer solutions, but that's not the case. So how can we possibly get x plus y plus z without actually finding x, y, z individually, because we're not able to find them here? So here's what we're going to do. We're going to combine these equations, okay, in an interesting way to get what we need. But in order to do that, for example, what I mean by that. So for example, one can try adding these 2 equations, right? If you add these 2 equations, do I get x plus y plus z or a multiple of x plus y plus z? Let's go ahead and check it out. If you add these up, you're going to be getting 58x, if I add these 2 equations, plus 10y minus 14z, right? And then by adding those 2 quantities, we're going to be getting 1,834. This is obviously not a multiple of x plus y plus z, so just adding those 2 equations is not going to help us. Or we might try subtracting, right? And especially since the first one has a smaller x coefficient, I can just go ahead and subtract this way. But again, if you do that, that's not going to give you the answer either. You're going to get 46x plus 26y, so on and so forth. So none of those are going to help us. What if I try to multiply one of the equations by some constant and then add it to the second one, vice versa, right? But that's not going to help either. Well, we don't know yet, right? That's the problem. So what we're going to do here is we're going to find some constants that are appropriate to multiply the equations by, so that when we combine them, when we add them, we're going to get a multiple of x plus y plus z. But how do we achieve that? Now, there's actually a really, really cool way of doing it. So here we go. I don't know those constants, so I'm just going to assume that the first constant is k. So I'm going to go ahead and multiply the first equation by k. And then I'm just going to go ahead and multiply both sides, of course. So that's going to give me 524k on the right-hand side. And then the second equation I'm going to multiply by m, which is another constant. So let's go ahead and do that. Let's see what we get from here. And the right-hand side is going to be 1,310m. Okay. Now my goal is to get a multiple of x plus y plus z. So what I need to end up doing is basically add these 2 equations. So I'm going to go ahead and add them. Okay. When I add, I'm going to be getting 6k plus 52m multiplied by x. And then plus negative 8k plus 18m multiplied by y plus negative 15k plus 1m times z, and that's going to equal 524k plus 1,310m. Okay, so what am I looking for here? Well, I want a multiple of x plus y plus z. In other words, I want the coefficients of x, y, z to be all equal to each other, okay? Because if I get something like, let's say, 8x plus 8y plus 8z, I can take out the 8 and I can get the x plus y plus z from there. Obviously, for particular values of k and m, this is going to be a number that I can just divide by, okay? All right, so let's go ahead and do this. Since I want all the coefficients to be equal, because I'm looking for x plus y plus z, then I'm going to set up this equality here. 6k plus 52m needs to equal negative 8k plus 18m, and that needs to equal negative 15k plus m. Now, this is kind of like a system of equations, but there's only 2 variables. Let's go ahead and see what that means. let's take a look at the first two equations. From here, I get 14k equals, if I go ahead and subtract 52m, I would be getting negative 34m. If I divide both sides by 2, I get 7k equals negative 17m from the first two equations. Now, second and third equation gives me, let's see what happens. I'm going to go ahead and bring the negative 15k over here as a positive. So it's going to be 15k minus 8k, which is 7k here. And then I'm going to subtract the 18m from the m, which is going to give me negative 17m. So what happened here? That I got the same equation, which means that we're actually able to find x plus y plus z. Okay? So the system is consistent in that sense. So what I need to do then is choose appropriate values for k and m such that I can get what I need. Well, once I do that, I can find out what's going to happen on the right-hand side as well. So what are some appropriate values for k and m? Well, k and m can be any number. Doesn't matter, but I'll choose integers. So let's go ahead and pick an integer value that would work. So for example, if I pick 17 for k, then I will have 7 times 17 here. So I need to have the same thing on the right-hand side, meaning that m needs to be negative 7. And those are basically 7 and 17 are relative prime. So there are no smaller values that satisfy this in terms of integers, okay? So let's go ahead and proceed from here. So what I need to do now is, I know that k needs to be 17 in my solution. So what I'm going to do is I'm going to go ahead and multiply the first equation, the original equation, by 17. So I'm going to be getting 17 times 6x minus 8y minus 15z, which is equal to 524 multiplied by 17. By the way, this is going to equal 8,908. And then I'm going to go ahead and multiply the second equation by m, which is negative 7. So I'm going to go ahead and distribute next time. 52x plus 18y plus z inside the parentheses. And on the right-hand side, I have 1,310 multiplied by negative 7, which is the value of m. And 1,310 multiplied by negative 7 is going to be negative 9,170. If you know 13 times 7 is 91, this should be easy. Okay, so now I have these two equations. Let's go ahead and arrange this a little bit. Let's see what happens. So I'm going to go ahead and multiply, distribute this. 17 times 6x is going to be, if you multiply, go ahead and it's going to be 102x. Okay. And that's going to be minus 136y, okay? And that should be 255z, if I'm not mistaken. That should equal 8,908. And then on this side, in the second equation, I should distribute the negative 7. If I multiply that by 52, that's going to give me negative 364x minus, and I think we already know 7 times, well, that was 8 times 17, never mind, right? Okay, that should be 126y with the minus sign, and then finally I should be getting negative 7z. And on the right-hand side, I should get negative 9,170. Okay, now, I was able to manipulate both of my equations with constants, so that when I add these two up, I should be getting what I needed, according to my calculations, right? So let's see what happens here. We're going to add 102 and negative 364. In other words, we're going to subtract and take the negative sign. That's going to be negative 262x. And then if you go ahead and do the calculation here, you should be getting negative 262y minus 262z. And if you go ahead and subtract these two numbers, you should be getting negative 262, which is fairly interesting, right? But this should not be a surprise, because when we did our calculations here, we wanted to achieve the same coefficient for x, y, and z. We didn't know what was going to happen on the right-hand side, but we ended up with a really nice value. Of course, the way the problem is written by myself, I wanted it to be that way. so that the numbers were kind of nice. Okay, so this should not be a surprise because x, y, and z should have the same coefficient from the very start. Okay, so the rest is actually fairly easy at this point, and we're looking for x plus y plus z, so all we have to do is take out the negative 262 and then factor x plus y plus z. That should equal negative 262. And if you divide both sides by negative 262, you will be getting x plus y plus z is equal to 1. Now, is this the only way to solve this problem? Of course not. There are other ways to solve it, so please go ahead and write it in the comments. If you have any ideas, feel free to share with me, comment. Thank you for watching the video, and our challenging problems series will continue. And see you guys next time in the video. Have a good one. Bye-bye.